Previously we spoke of the indefinite integral, and if we had a function such as the following and we integrated it, we got a new function as follows with a c at the end of it. And this c was called the constant of integration, and it could have many values, which meant that the integral had no definite value, hence it was indefinite. Now we can apply limits to such integrals, and they then become what we call definite integrals. They can be written as follows, and this represents the increase in the value of the function as x increases from 1 to 4. Now we evaluate the definite integral as before by first evaluating the indefinite integral and then placing it inside square brackets with the limits shown. We then substitute the limits and subtract to give the following. And when we calculate this out, we get minus 93.15. Now as you can see, the arbitrary constant of integration cancels out, which is always the case, and it is not normally shown when we do the calculations. So here's a problem that you could try. Integrate the following function between the limits 1 and 2. So remember, integrate the function as normal to give the indefinite integral, and then substitute 1 for x to give one value of the indefinite integral, and then substitute 2 and subtract the two values. We saw previously that integration could be considered a summing operation. In fact, when we integrate a function between two limits, say a and b, we are in fact determining the area under the curve between these two limits. Now in the diagram, if dx is very small, then the area of the solid red rectangle can be approximated as y, its height, multiplied by its width, dx. Now if we divide the whole area between a and b into small similar rectangles, summing them up, in other words integrating, gives us the area under the curve between a and b. In this next question, we're asked to find the area enclosed by the curve y equals 4x squared plus 2, the x-axis, and the ordinates x equals minus 2 and x is equal to 1. So once again, pause the video and see could you try this question. And the answer is approximately 9 square units. Now, we don't need to plot the function, but if we did, we'd get a curve something like this as shown. And we're trying to get the area between the two limits a and b, or between minus 2 and 1. Now, if you remember, the area under a curve is given by the integral between a and b of y dx. So in this case, y, or the function, is 4x squared plus 2. So if we substitute that and substitute the limits, we need to integrate 4x squared plus 2x between the limits minus 2 and 1. So if we integrate this, we get 4x cubed over 3 plus 2x squared over 2 between the limits 1 and minus 2. So substituting first 1 for x and then minus 2 for x and subtracting, we get an approximation of 2.33 minus 6.67. And this is approximately 9 square units. So the area under the curve between the limits minus 2 and 1 is approximately 9 square units. So here's a final question for you to try. Find the area enclosed by the curve y equals 2x squared plus 2x minus 2, the x-axis, and the ordinates x equals 1 and x equals 2. So this is the area shown in yellow on the diagram.